Hello, this is Whipsales again, and welcome back to part 3 of how to build a Computercraft controlled nuclear reactor. In the first part we went through how to build all the components, how to put them together. In the second part we did look at how to connect all the signals to the computer and how to display them. And in this episode, this will be a long and boring episode. I do warn you, there will be a lot of me coding, a lot of me muttering, a lot of me being frustrated and so. Because I did try out some in the beginning. I did learn how to actually cool off in the reactor, and this is how. And I think it will cool off. Yeah, we'll just let it cool off. I did some changes since last episode. First of all, I added one signal. What can this be? Because I wanted to add a feature to this control system, and that would be this one. What I do want, in addition that this reactor will work on the tempo range from this to, like, from level 2 to level 3. I also wanted to stop when the MFSUs are full, but I also wanted to start automatically again when the bank starts to get low. So basically you can place this everywhere, anywhere you want in your bank, and when it reaches this level it will turn on. As you see now, it is turned on because the MFSU is set to emit if partially filled. It will not emit if empty, not emit if it's full, but if it's partially filled. That's a pretty neat thing. It will send a signal over to this sine cable, which is, well, this was 256, this will have the value of 512. I also did some minor changes to the program. I did nuclear. Where's my R? There's my R. I did add a variable MFSU low, and I do read it down here. I did change the way I read the values. I just made a function which is much shorter than the rs dot test bundled input blah 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 blah. And the nice thing is that instead of this actually works where you can write colors dot pink, for example. It does recognize this as a number, which was pretty cool. And I think this is a better way to program. Instead of making the functions handle variables which you don't see, you actually can read out from the functions the results, and this is like using a function repeatedly. I also made a function, did remake the temperature level function. So now I'm actually calling up the function, and the function is returning the temperature level. I will show you the two changes. Here is the read input. Instead of the long line with rs test bundle input, I just pass over the parameters side and color, and it returns if it's true or false. Easy peasy. And the next thing is reading the temperature level. Instead of having all these variables defined in the top, I'm only using as a local variables. These are not visible to the rest of the program, and it doesn't have to. And let's turn off the rain. Can you hear me over the rain? Okay, so what this does, it reads all the inputs, and in the end of the code, which you have seen me make in the last episode, it just returns the temperature level. It's easy as that. I think it is better programming, but I'm not usually a text programmer. I do program almost on a daily basis, but not with text. It's graphical based programming. So what we will do today will be long and boring. We will first make the system. Let's just make some comments. Make some control system, and then we need state check. This is the two next things we need, and I believe the control system is easiest to start with. We have, I believe, three things which can stop the reactor. But before that, we'll make two functions. Just because it looks tighter, is the function start reactor. We will make, and we'll make function stop reactor, so we don't have to think about this. And this will just be rs dot for the stop set bundled output on the left side. I do see the error. I will correct it. Yes, this will stop the reactor, and to start it, it's rs dot set bundled output on the left side to 32. Double checking spelling, that's great. And I also found another bug while checking. Oh, I have corrected it. It was saying variables and not variables. Very. I hate English. Okay, so now we have a function to, we can just call the function start reactor to start it and stop reactor to stop it. That's cool. And let's define what will not start. I think it's a weird way to think. What will not start the reactor? Because we have to define three variables, and that's the three things which will make sure that it stops. And that is, if we have an emergency shutdown, which we will not have in the beginning. It's if it's cooling, we do not want it to start, and if it's power off from the MFSUs. Okay, so this is the three things which can stop it. Let's say so. If ESD or cooling or what was the last thing? Power off, which is the three things I want to stop it with. Then I will go stop reactor, and else start reactor. Wow, I mean, that was pretty easy compared to what I've been programming. Well, my previous program. My previous program was way complex, and I think this is yeah. If you have emergency shutdown, or it's cooling, or it's power, it wants to power off, stop the reactor. If you do not have any of these, okay, please start the reactor. Okay, so now we need to define how we turn on and off the different states there. The emergency shutdown we only want to activate if the temperature level reaches above level 5. So if temp level gets above or equals to 5, then ESD equals true. Okay, that's great. And to turn the emergency shutdown off again, I wanted to turn off after it stopped completely, so I'll make it later, but this will make sure it stops. And then we will have what will start the cooling. If temp level is greater or equal to 3, then cooling equals true. So this means if it's temperature level 1, 2, 3, if it's greater or equal to this, it will actually turn on the cooling, which will turn off the reactor. Okay, and to turn off the cooling, if temp level is below or equal to 2, then cooling. Could I just have an else if there? Yeah, I think it will be more tidy. Else if temp level is less or equal to 2. That's nice. Then we will turn off the cooling. Cooling equals false. Great. So if it gets above level 3 or equal to, it'll turn on the cooling and turn off the reactor. If it gets below this typo, temp level 2 or equals to temp level 2, it would turn on off the cooling and it will automatically start again. Nice. Okay, so now we want to have the power off control. If MFSU full, that means if it's full, we will say power off equals true. It's nice. And then if MFSU is low, then power off equals false. Simple as that. So that means if it's full, turn on the MFSU, it will actually stop the reactor because this will be true. And when it's low, it will actually remove the power off and will start the reactor again. Okay. Okay, let's make the on for the ESD again. Because this, when you have an emergency shutdown, I wanted it to shut completely down to level 0. I wanted to go below this point and say this have been overheating, and do you want to start up the machine again, check the cooling or something like that. And I believe the best place to place it is unfortunately after here. Is here. Yeah, because of the update screen. No. I think it'll be okay. Let's see. Maybe we'll just have it here anyways. I think it'll be okay. Just thinking for myself, programming as we go. If you have emergency shutdown and temperature level equals to 0, because that will actually be below the lowest one, right? That's cool. Then we want to type print. First we want align shifts just to make it look neat, and we want to say reactor stop cause of overheat, and do like this. Do a period, because we do use punctuation. It's nice to use punctuation. Please, let's be polite as well. Check the cooling. Nice. And then we print press any key to start reactors. This couldn't be clearer, right? Yeah, and just to make it pause, so it just wait for any key, you can actually do like this. I don't think you need all these parameters, but I do them anyways, just of bad habit. Always dot pull event, and it will just pause at that point and wait for a key, and it will go on. And when it goes on, we take the ESD and we remove it. We take it to false again. So now we actually have a program which should be able to start and stop the reactor in the different states. So let's try. It's always a nice thing to debug. So if we start this one up, it should go to default, of course. Nuclear. It went amazingly smooth in the last episode, so I was expecting a lot more errors. So I feel kind of lucky. Okay. Didn't say 84 or something. It did say 80 something. I did expect function stop reactor rs set bundled output left. I think I need to run it again. It says 84. No, I don't believe you. That's the right line. I think it sometimes can confuse you. Edit nuclear. I don't think it's the error is in line 84, and it was expecting a sign of equal. Aha! It wasn't line 84. Kill me. Nuclear, and it starts up. This would be starting at once, and since there is no uranium here, I'll just remove the cooling. I'll learn how to cool it. Probably not the right things to use, but okay, we'll put in some uranium, and you will see it will heat up quite fast. And how we programmed it, it will go up to 4000 and it should stop around 4000. Yes, still rising, still rising. Let's see the temperature. 1824. You think I can manage to make noodles before it reaches 4000? Yeah, let's just decrease it 500 so it goes faster. Okay. Wait for it, wait for it. It turned off. Great. So now it should actually be in cooling mode. And let's help it cool down. Okay, let's see. Okay, it started again. No. Because it is in level 2. As long as it's above this, I want to go below, so I need to actually change that. This is why we do debugging nuclear and edit nuclear. I wish I had like page down to the bottom. Okay, we wanted to turn off the cooling if it was level 1 and below. Okay. Now it will try to heat up again. Let's just be nice and simulate this and take it just a bit more. How warm are you? You are... I need to go down 100 more. And it will turn off the reactor. Great. It will keep cooling until it's below 1000. Let's increase this just to simulate this. Oh. And it should start. My oh my. How's the temperature now? Okay. So it has started the reactor again, and it will keep it going until it gets up to this temperature. It will go down and back again. Now let's try the emergency shutdown. Let's see, there's nothing happening here. You see the state is still unknown, but that is the last thing we'll make. First we will make how we'll manage this to control. Let's see, emergency shutdown. This is cooling off quite slowly. That's nice. Let's just take out some of these. The way to actually simulate the emergency shutdown is to decrease this, so you actually get temperature level 5. So if I do this to 500, I should get temperature level 5, I should get emergency shutdown, and it will shut down the reactor completely. Let's turn this up again to 6.5. Still not turning it on, and it should wait until it's oh, it should why did it start so fast? I wanted it to start on temperature level 0. You see, now I can start the reactors again. I can press enter and it starts on temperature level 0. Why did it come that fast? Nuclear. Let's figure out why did it do that. If temperature level is about, set it to true. If ESD, it shouldn't print it until it's temperature level 0. Oh yeah, of course, it's temperature level 0 when it's below this one, so it was correct. I did apply start again, but why did it say stop applied? Nuclear. Stop applied false. Okay, that's true. That's yeah. Stop applied is false. That's true. Okay, so now it's heating up again. Now we want to test if this one is full. Let's just reconfigure it to emit if it's empty. Okay, and it doesn't work. Why you no work? More debugging. I think I'll just, for safety, I'll put in some more cooling. I don't want to risk it blowing up while I'm standing here programming. I'm gonna go like, Wah! Okay, why do you not? I know why, because this one is high. Those are not supposed to be high at the same time. Nuclear. I need to make this one low, so let's say if it's if it's empty, and it will stop the reactor. And what will happen if this one will be more empty, and it will stop producing a redstone signal, and it will still be stopping the reactor. That's good. And once this one you can move wherever you want, so if you want it to start filling out again when this one is empty. That was actually a niche idea. I could actually connect it to the other side, but you can connect it to any other MFSU and say if it's partially filled, this one is partially filled. Let's see, do nothing, emit it full, emit it partially filled, and it will start the reactor again. And we have a working reactor. It's starting and stopping just as we want. Cool. Let's see. Yeah, I think I'll divide this episode up in 2 parts, because this took some time. Because now what we are missing with our system is all the states this machine can be in, and that's such a pain to to actually to code, because there's so many combination of if this signal is on, if this is off, this is on, this is on, this is on, and this is not doing anything, please say I'm doing this. And we actually done with a very easy part of the control system, and that is making to start and stop. And why do you want the state? Because we want the information presented very easily. So I'll just cut the video here, and I'll be right back. The emergency shutdown have stopped the reactor. Is it still meltdown? No. It is a meltdown if it's emergency stop and not stop applied. Because if it's not trying to stop and the emergency shutdown have gone off, you do have a meltdown.